Okay, so as in the last video, we have discussed about all the characteristics of the wave. In today's video, we'll be discussing about the difference between mechanical and electromagnetic waves. Alright, so our today's topic is what? Is the difference between mechanical waves, mechanical waves, and electromagnetic waves. Alright, electromagnetic waves. Okay, so in today's video, we'll be discussing about the difference between mechanical waves and electromagnetic waves. As I told you previously as well, that mechanical waves are those waves which always require medium to propagate. Alright, if medium would not be there, they cannot travel. Alright, that is a simple thing. So, first one is what? They always require what? They always require medium to propagate. Medium. I'm writing here only require medium, alright. As I'm telling you verbally, they always require medium to travel. If medium would not be there, then mechanical waves cannot travel. If medium would be there, then mechanical waves can travel. Alright, while talking about electromagnetic waves, so electromagnetic waves are those waves that do not require medium for propagation. Alright, so do not require medium. Alright, if medium would be there, they can travel. If medium would not be there, they can still travel. Alright, so this is the major difference between them. If I to talk about the second difference, alright, so how mechanical waves are produced. So mechanical waves are produced by the vibratory motion in the respective medium. Alright, this is produced by what? This is produced by the vibratory motion in the respective medium. So here I am writing vibratory motion in the respective medium. Alright, in the medium. Alright, if I am putting a tuning fork in the medium, that is air. Alright, if I am putting a tuning fork in a medium, alright, and I am striking a hammer to this, alright, a hammer of rubber, alright. If I'll strike a hammer to this, they'll start vibrating, alright, and if this will vibrate, this will produce a sound. Alright, so this is basically a vibrating material which I have put in the air, and if that will vibrate, they will produce the mechanical waves. Alright, so that mechanical wave can be longitudinal, or that can be transferred as well. As I told you about the turning fork here, so turning fork will produce the sound, and sound waves are the longitudinal waves. So here in this case, when I make a turning fork, so here longitudinal waves will be produced. Alright, and if I do talk about electromagnetic waves, so electromagnetic waves are produced by changing of electric and magnetic field. Alright, they are produced by changing of electric field and magnetic field. Alright, if I'll change the electric field or magnetic field of any like substance, so they will produce what? They will produce electromagnetic waves. Alright, so I'll be telling the examples of these as well, no need to worry. Alright, so now what mechanical waves are consist of? So mechanical waves are consist of transverse as well as longitudinal wave. Alright, so let me write this here. We have the third one. They can either be transverse or longitudinal waves. Longitudinal waves. Alright, example, if I do talk about transverse waves, alright, if I am throwing a stone in the water, it will produce waves. Alright, those waves would be like this. If this is water, I am throwing a stone. Alright, so this would generate waves. Alright, this would be like this. So these waves are what we call the transverse waves. Alright, so if I do talk about longitudinal wave, as I have given you an example, this is the turning fork I have. Alright, if I am striking a rubber hammer to this, they'll start they'll start vibrating, and by vibrating this material, this will produce the waves, which are longitudinal waves, and these are also known as sound waves. Alright, so this was the example of longitudinal waves. If I do talk about this electromagnetic waves, so electromagnetic waves are always what? They are always transverse. They are always transverse. Alright, they are always transverse. Now if I do talk about mechanical waves can travel through medium or not, so mechanical waves cannot travel through the vacuum. Alright, as they always requires medium to travel, mechanical waves, and in vacuum we know that we don't have any alright, any medium in the vacuum, so they will not, do not, this is fourth one, sorry, they do not travel through vacuum, just because in the vacuum uh, medium is not present. Alright, and they always require medium to propagate. So electromagnetic waves can travel through vacuum, can travel through vacuum, through vacuum with the speed of, like there is a speed of that as well, that is 3 into 10 to the power 8 meter per second. Alright, so this is the speed of electromagnetic waves in the vacuum. Alright, so if I do talk about the examples of electromagnetic, not electromagnetic but mechanical waves first, so we do have examples. Alright, those can be sound waves, sound waves, alright, water waves, water waves, then we have seismic waves, seismic waves. Alright, they are some example of the mechanical wave. But if I do talk about electromagnetic wave, so here we have radio waves, here we have microwaves, microwaves. Alright, here we have infrared waves, infrared waves, here we have ultraviolet waves, and here we have x-rays, here we have gamma rays as well. So these are some example of what? Some examples of the electromagnetic waves. Alright, so here in today's video we have discussed about the difference between mechanical wave as well as electromagnetic waves. Alright, so this was all for today.